guys, today we're going to move on and we'll talk about the absolute value function. And if you can recall, the absolute value function is one of our parent functions. It is the function that says f of x is equal to the absolute value of x. Now, before we get into the absolute value function and how it looks graphically, I want you to take a second and just pay attention to how your notes look this time around. You have a column to the left that says main ideas and questions, and just use your space, guys, to write any questions that you have as you go through the video. Then I want you to come into class. You'll have your questions with you when we start to do our practice on Monday. Now, I want you to recall back in Algebra 2, you learned about the absolute value function, and you learned that the absolute value represented distance, okay? This is actually the distance any number is away from 0. All right, so in my main idea, I'm just going to take a quick note and I'll just say absolute value AV is distance from 0. Now, I want you to pause the video, and I want you to take a second and just evaluate the absolute value function on the table, right? So you're going to plug in these x values and see what the outputs are. And then I want you to graph the absolute value function. Now, do I expect you to take a lot of time graphing this graph? The answer is no, because this is one of our parent functions. So we should already have an image or a visual of what this graph looks like. After you graph the graph, I want you to tell me what the domain of the graph is. Use your great interval notation and tell me what the range of the graph is. All right, guys, did you get what I got? If we're going to recall first that the absolute value function is in that shape of a V. If I look at the center of the graph, I notice that its vertex lies at the origin, 0, 0. That is important. All right. The domain of the absolute value function, well, if I talk about domain, remember that's all the x's. Well, if I look across, I notice that it would be all real numbers graphically, right? Everything. And if I think about this algebraically, I know I can plug in any number into the absolute value function, and I would get an output. So I know it's all real. If I talk about range, remember range is the y, so that's when I look at the graph up and down. And I have to think about this. This makes a lot of sense. Okay, if I look at the graph starts at the origin 0, and then it just goes up to infinity. So that's the arrows here, right? If I look at this algebraically and think about my output or my y values after I take the absolute value of a number, regardless if that number is negative or positive, the absolute value will always give positive answers or answers greater than or equal to 0. Why is that? Well, again, because the absolute value is a representation of distance. All right, let's take a moment and let's fill in what we know about the absolute value. The first thing is that it looks like a V, and it has a turning point. Turning point just means, let's think about that vocab, turning point. Turning point means when the direction of the function goes a different way. Okay, so a change in direction. So write that the turning point is a change in direction. Well, if we analyze the graph above, we notice that the turning point or the change in direction of the graph happens at the origin. Okay, the graph is going one way, and then the graph turns and goes another way. That happens right at the origin, which is called the graph vertex. Okay, so this happens at its vertex. So let's talk about the steps to graphing absolute value functions. Okay, we graph the parent graph, but what we're going to do is we'll change the graph around. We're going to make some children, okay, and you'll see how all of the children look just like the parent graph. Now, I'll tell you guys, if we can do this with the absolute value graph, if we get a hang of this, we'll be able to do this for all graphs. So our goal today is to be able to graph absolute value functions using a table. And I also want to go over with you graphing the absolute value functions using your graphing calculator. So make sure you have your graphing calculator out and ready to go, because we're going to use our calculator to check our work. Now, the steps to create a table of values for absolute value functions follows this simple order. It's best to place the vertex of the absolute value function in the middle of your table, and then include the values on both sides of the function, okay? And when I say both sides, once we find our vertex, so in the case of the parent graph, we find our vertex to be at 0, 0. Then we're going to look at the left side of the absolute value function, which means we'll look at negative values, and then we'll look at the right side of absolute value functions, which means we'll test positive values, right, on each side of the vertex. Now, to figure out where the vertex is, we need to find the x value of the vertex, okay? And that's just simply by setting the expression from the inside of the absolute value bar is equal to 0 and solving for x, okay? We're going to place this value in the middle row of my table, and then we'll number up and down to complete each side of the table, and we'll graph. Very simple. So let's go through the steps. I'm going to graph some, and I'll give you the chance to graph some and let you check your work. All right, let's start with number 1, which says we're going to graph the function and then state the domain and range. Now remember, the first step is to figure out the x-coordinate of my vertex. I'm going to take what's inside of the absolute value, and I'll first set that equal to 0 and solve for x. So I'm taking x minus 4. I'm going to set it equal to 0, and I'll solve for x to figure out the x-coordinate of my vertex. Well, that would mean that I add 4, and that means that the x-coordinate for my vertex is going to happen at x equals 4. Okay, so I know my vertex is when x equals 4. So I'm going to put that in the middle of my graph. Now figure out what the output is, or what f of x is, or the y is for 4. So I'm going to plug that back in my equation. I'll find f of 4. Well, f of 4 obviously is 4 minus 4, and that is just 0. Okay, so I know my vertex is at 4 is 0. My next step now is just to test values on each side of 4. So I'm going to test 3, and then I'll do 2 and 1. And then on the other side of 4, I'll do 5, 6, and 7. So now I have both values, or both sides of that vertex. So let me evaluate each of these values. If I plug in a 1 to the function, or find f of 1, I would end up with a negative 3 inside the absolute value, which I know is just 3. Absolute value of negative 3 is 3. If I find f of 2, I would plug that into the function, and I would have inside of the absolute value 2 minus 4. Well, 2 minus 4 is negative 2, and the absolute value of negative 2 is 2. If I plug in a 3 into the function, or f of 3, I would have 3 minus 4, and 3 minus 4 is negative 1. Absolute value of negative 1 is 1. Now I go on the other side, and let's get our bigger values. I'm going to just make this a 0, a better 0, because it kind of looks like a 6. Alright, so if I plug in a 5 into the function, I would end up with a negative, or I would end up with a 1, sorry. So I know that the absolute value of 1 is just 1. If I plug in a 6 into the function, I would end up with a 2. Absolute value of 2 is 2. And a 7, I would end up with a 3. Absolute value of 3 is 3. Right, now I'm going to plot each one of my planes. I'll go ahead and change the pen, but I know at 1, I'm at 3. At 2, I am at 2. And at 3, and forgive Miss Bennett, I got to move my vertex over. Guys, bear with me, my eyes are not as good. So my vertex is not at 4, 0. There we go, now it's at 4, 0. Okay, so at 3, I'll be at 1. On the other side, at 5, I'll be at 1. At 6, I'll be at 2. And at 7, I would be at 3. And notice I have the graph of a nice absolute value function. Right, I'm going to have you pause the video, and I want you to now go through the steps, and I want you to graph the absolute value function for number 2. Figure out where your vertex lies, and then graph each side of the absolute value function. All right, did you get what I got? If you did, awesome, awesome. All right, let's talk about domain and range of both of these graphs. So if I look at number 1, if I talk about the domain, or all of the x values, I realize I can plug in any number for x, okay? So the domain of this graph is still going to be all real numbers. So that's negative infinity to infinity. Talk about the range of this graph. So look at the range. The range is going to start at 0, right? And it's going to be a bracket because it includes 0. And then it's going to go all the way up to infinity. Over here, if we talk about the domain of number 2, well, again, we're still at the same place where we can plug in any value for x. I see this graph covers the entire x-axis, so it's going to be all real. All right, and then the range of the graph, the same. We start at 0, and then the graph moves up to infinity. So we're going to include 0 all the way to infinity. Okay, now I want to take a quick second and just check my work using my graphing calculator. Remember to graph functions, we're going to use this y equals. All right, so I'm going to hit y equals, and that takes me where I can graph this function. I'll do a quick check on my window and just make sure my window is not weird. Remember, window is how your x and y axis look. And my window is from negative 10 to positive 10 for the x-axis and the same for the y, so we're good with that. I'm going to go back to y equals, and remember, y is the same thing as f of x. So my function is already solved for y, so I'm good to go there. I need to just type in the equation. Now, the trick here is knowing where the absolute value symbol is on your graphing calculator. You'll find the absolute value symbol, and you can write this on your notes to the left column so you don't forget it. But the absolute value symbol is going to be found under the math key. You'll hit math. You're going to scroll over here where it says num. So just scroll over to num. Notice you have the choice 1 is add. That's the absolute value symbol. So just go ahead and hit 1 or hit enter. Then notice the absolute value symbol pops up. I'm going to go ahead and type in the function x minus 4. And remember, for x, we're going to use this key for our variable x. Okay, so x minus 4. And then I'll come out of that, and I'm going to hit graph. Look at that. It graphs my absolute value function, and it looks pretty solid, right? Looks really good. So I am good on that one. Let me check my other function and just make sure I did good graphing this function. So I'll go back to y equals. I'm going to clear out this graph. I'll hit my math. Go over to num. Click enter. And then I'll type in my absolute value. I got 2x plus 6. And then I'll leave that and I'll hit graph. When I hit graph, I'm looking and it looks like I did a great job. Yep. Looks pretty solid, don't it? All right, let's graph the next absolute value function. And notice it looks similar to the first problem. The only difference is we have this negative on the outside of the absolute value. Let's see how the negative affects our absolute value graph. I'm going to start by finding the vertex. So again, I'm going to set what's inside of the absolute value equal to 0, and I'll solve for x. So x plus 1 equals 0. If I solve for x, I end up with x equaling a negative 1. So I know the vertex for the x value is going to be at negative 1. I'm going to put that in the middle of my table. Now I need to find out what the output is. So I'm going to find f of negative 1. And Ms. Bennett's kind of doing this in her head, but I already out f of negative 1 is going to be a negative absolute value of negative 1 plus 1. Well, negative 1 plus 1 is 0. You can't have a negative 0, so this is just going to be 0. All right. Now I'm going to check each side of the absolute value. So the positive side would be at 0, 1, and 2. And the negative side would be at negative 2, negative 3, and negative 4. So let me go ahead and evaluate all of those values. I'm going to plug in these values to get what the absolutes are. All right, I found my values and I went ahead and plotted my points. And now I want to just check and make sure I did the graph correctly. Let me go ahead and use my calculator. And I'm going to go to y equals on my calculator. I'll clear out the last function. Hit the math key, I'll scroll over the numbers, and I'll hit the absolute value key, and I'll type my function in. Plus 1. And then I'll hit graph. I know what Miss Bennett did. Miss Bennett grabbed it, so I got to put my negative in my function. So I'll do a second and a insert. All right, now there we go. Yes, my graph is on point, so I did pretty good. So now, what I want you guys to do is to pause the video, try to work through the next problem. Again, figure out where your vertex is, find its output, and then plot the points on each side of your vertex. All right, did you get what I got for the second graph? I want to know that our vertex is going to be at negative 2. I chose intervals that were by 2 from negative 2. And the reason why is because my function, I'm dividing by 2 every time I plug into the function. So I chose to go by intervals of 2 so I could have nice y values and I didn't have any strange fractions. So just keep that in mind, guys. Let's go ahead and check our function with our work. Let's see how we did. Let's clear all of this out. I'm going to go ahead and type in my function. So we got math, we got absolute value of 1/2 x plus 1, then minus 4, and we are right on the money yet again. The calculator is great. It confirms my work. All right, let's discuss domain and range of these two graphs. Now, if I look at the first graph, the domain, again, if I look, I'm not restricted. The domain is all real numbers, right? So I can go from negative infinity to infinity, all real numbers for the x value. Let's look at the range of this graph. Now, the range this time, it starts at 0, it starts at 0, but then we go down to negative infinity. So we have to write this backwards, okay? We want to start with our negative value. So we know this is coming from negative infinity, and end, because this graph is going down, we end at 0, and we want to include that. Let's look at the domain and range for this graph. Again, any number can be plugged to the x value, so my domain for all real numbers for the x value. So let's look at the range for this graph. This graph, I start at negative 4, and then I go all the way up to, and so for my range, I'm going to say, hey, my range starts, it includes negative 4, and then it goes, all right, let's move on to the last two graphs, which are our piecewise graphs. We're going to go ahead and graph piecewise functions, but this time we'll add in the absolute value functions, because now we're pros at graphing absolute value functions. Let's go ahead and go through our same steps of graphing the piecewise function, which is first establishing what my boundary points are, and if they're of circles. So if I look at the conditions set on my piecewise function, I realize x is less than 4 or x greater than or equal to 4. So I know 4 is the start. So I'm going to go over to 4. And I just said my interval is going to start here at 4. This is like the smallest graph, so it's finished. Here we go. All right, the next thing's next. We're going to go ahead and do the same thing that we did. We're going to find out where our points go. We're going to find my boundary point for the first graph, or when x is less than 4, I'm going to plug in 4 into the top part of the function. So I'll find f of the top part. F of negative 2 times 4 plus 1. And I know f of negative 2 times 4 plus 1 is a negative 8 plus 1, which is a negative 7. And so I'll go ahead and plot that point. I know it's an open curve. So I go over to 4. And I'm going to go down to negative 7. And I know it's all my values on the left side of 4 because it's the values that are left. So I'm going to start plotting my line. And I know I can use this slope to go ahead and plot this. I can go down 2 and over 1 to get another point on this line. Because it's negative, I'm actually going to rise up 2. And I'm going to fall, or I'm sorry, I'm going to go rise up 2, and then I'm going to go to the left 1. So here we go. I go up 2, 1, 2, and I go to the left 1. So that's my negative. And I know another point on this line right here. Okay. I'll go ahead and I'm going to draw my line for the left side of the negative value. Now, I'll go to the next part of the function, which is when x is the absolute value of x minus 3. I'm going to go ahead and go through the same steps. Let's figure out where our point is at. Okay, so where does this break happen? We're going to go ahead and do that by finding f of 4 for the absolute value of x minus 1, where our boundary point is. F of 4 for absolute value of x, well, the absolute value of 4 minus 3 would be the absolute value of 1, which is just 1. So I know that for my values of x that are greater than or equal to 4, it's going to be at, now I'm going to go to 4, 1. I'm going to go ahead and plot my point, but this time it's going to be close. Now, I just have to plot another shape. But if we look vertex for this graph to be at x equals 3, right side and solve for x, which means that the vertex of this graph is going to be less than 4, which means it would not be in. So I'm not even going to have the left side of my v in my piecewise graph. I'm only going to have that right line of my v. So I only need to find one other point to draw my v, and I'm going to do a value that's greater than 4, and I'm going to go ahead and draw my v. And when I say v, I'm graph. So I'm only catching the right side of my absolute value graph, and I'm going to do that by plugging in a bigger than 4. So I'm going to try just an f of 5. All right. If I plug in 5 into the absolute value of x, the absolute value of 2, which is, so I know another point on this graph is going to be at 5. So I'm going to go ahead and go over to 5 and go up to 2, which is right here. And now I can go ahead and graph the right side where my value is greater than 4. And that's it. Here's my piecewise function. Now, I want to check my work with my calculator. Can you believe it? Your calculator actually checks work. So I'm getting my calculator out, and I'm going to check this piecewise function. I'll show you guys how to do it. So if you have the TI-83, it's going to be this who has the new calculator. For the new calculator, I'll go ahead and link a video because your steps are going to be pretty simplistic. TI-83, TI-81, we got to do a little bit more work. Not too much, but a little bit more. Or we're still going to go to y equals, guys, to grab a piecewise function. We'll go to y equals. We'll clear everything out. I am going to type in my function, but this time I'm going to type it in. I'll type the first part of the function. So I will have a negative x plus, and I'll put that in parentheses. Then I'm going to type the condition on the x is less than 4, but I'm going to put that in parentheses. So I'm going to say x, and to find my less than symbol, I'm going to hit second key this time, and I'll hit the math button. It takes you where it says test. And there's all of my symbols. I'm going to scroll down to the less than symbol and press enter, and then I'll hit 4. Now I'm going to do the same thing for the second piece of my function, which is the absolute value of x minus, but we know we got to find the absolute value, so we hit math. Oh, wait, I got to go back to that y equals, so I got to put this in. So we hit math, then move over, okay, and then I'll type this in, x minus 3. Scroll over, I'm going to hit it in parentheses, and I'm going to add in my condition, x is greater than or equal to x. I'll go second, and then math is the logic. I'm going to hit that greater than or equal to button, which is option 4, and then I'll close parentheses, and that's it, guys. Once you got that entered in, just go ahead and hit graph, and let's check my work. Good, right? It was really good. The Bennett has got it. All right, let's go to the next one and graph the next one. All right, first let's start by finding our boundary point. So I went ahead and I found each piece's boundary part by simply putting the restrictions or the conditions inside of each piece, and I was able to figure out what the point was, the output was, when at value. Then what I did, because this one has more pieces than what we're used to, so I went ahead and just noted each interval what I'm going to have, an open circle or closed. So I got the first one's going to be closed, second one's open, third one's open, and the last one is closed. Now I'm going to go ahead and plot the points. So yeah, I'm plotting my points now, and I'm just going to go ahead and think about what the graph of each interval looks like and graph that graph. So the first graph is going to be an absolute value graph. It is 2x, and if I look inside under the vertex for this graph, it's actually at 0, 0. You take 2x and set it equal to 0. So this vertex is at 0, and I'm sorry, it's not at 0, 0, so it's at 0, negative. Now 0 is greater than negative 3, so 0 would not fall on our interval, so we know we're only going to get the left side of our absolute value graph. So over here, where I'm at 3, or negative 3, negative 2, or negative 3, positive 2, I know I'm only going to get the left side of my absolute value graph, not the right, because the vertex is over at 0, so only the left side of the graph. With that being said, I just only need to plug in a point less than negative 3. What Ms. Bennett will do is I'll plug in a negative 4. So if I plug negative 4 into this equation, I'll end up with negative 8 inside of the absolute value. And the absolute value of negative 8 is, of course, 8 and 8. So I know when I'm at 4, or negative 4, I'm going to be up at 4. So here I am at negative 4, or I'm right here. And I can go ahead, I have enough now, I can just go ahead and draw that line. I know this piece is going to be so it's the part of the absolute value. The next thing, I have f of x is negative 5 when x is between negative 2. Well, remember I said as long as we know what the graph looks like, we're good to go. I know when a function is just equal to a constant, and it has a 0 slope, that this is just going to be a horizontal. And that's exactly what we have here. This is a graph between negative 3 and of a horizontal line and negative 5. So we got that interval. The last interval, of course, this is the shape of a line. So we know the slope of this line is 1. So I just need one other point, right? I'm going to start with my boundary point, and then I'll go up 1 and then over 1. I've sketched this piecewise graph, and let's go ahead and check our work. We are going to go to the y equals. All values in separately, and then you have to add a conditional statement. So what we're going to do is we'll separate this statement. We'll say x is greater than -3, and then we'll add that conditional statement of the word and then we'll say x is less than 2. Okay. So how I'll enter this in is I'll do my parentheses still. I'll say -5, right? Okay. And now I'll put my second parentheses. I'm going to start with the first condition, but I start with x. I'm going to say x is greater than -3. So I got x, and then I go to second test. I go to greater than, and then I'll do a -3. And then I have to add my conditional statement. I find the conditional statement by doing second test again, but I'm going to scroll over to where it says logic. There I see the word and. So I'm going to hit enter, and pops in. Then I'll do the next part of this statement, which is that x is less than 2. So I'll do x, second test, down here to less than, and then I got 2. And I'm going to close my parentheses. Now what this does is it establishes to the calculator how far it's going to plot the line for the second part of my piecewise function. Now the rest of it I just enter the same. So I put my parentheses, and I do x minus 2, and parentheses, start my condition, second test, or second, and then I have this time x is greater than or equal to 2. So I go down to greater than or equal to, and I didn't enter my x, so I got to do second enter, and enter my x, and there we go. And now I'm ready to graph this thing and check my work. And now look at my graph. Now either I did something wrong on my graph, so it looks like my work is good, or the calculator did something wrong, and this is good. Sometimes these things happen. So I'm just going to go back and just check and make sure I entered in the value correctly. And I think I know what I did. So my value, I put -5, x is, and I put that x is, there we go. I put x is going to be less than. So instead it's going to just fix that, right? Second, test, and I got to fix that symbol. X is actually, and now let's go ahead and graph. Look at that. Yes, my graph is on point. All right. If you struggle using or graphing piecewise functions, you can use your calculator as an aid. The big thing that you do have to know though is that your calculator is not going to graph your open circles or closed circles, so you need to know how to find those based on your interval. If you have a new calculator, Ms. Ben is going to post a video so you can see how to graph. It's so much easier on these calculators, like 2 steps. Also, guys, let's check out the domain and range of these 2 graphs, and then I'll have you guys work on some sample problems tomorrow. So let's look at the first graph. If I talk about the domain of this, or the x value, I notice that I can plug in any x value. All right, it's still the same. Even though they're in pieces, it covers all x values. So I know that the domain of this is from -infinity to infinity. That is my domain of all of the x values. Now, if I talk about the range of this graph, well, I got to be careful. The range of this graph, it looks like it covers everything, but actually it doesn't. My range starts here at -7, and then it goes up all the way to infinity. And I need to understand that I'm not including -7, so I'm going to have a parenthesis at -7, and then I know the rest of this rise all the way out to, rise out to infinity. All right, last thing left, let's look at the graph that we have over here. Range, or domain. Domain's the easiest because I look at each one of the functions, and it looks like we're including all values of x. I can plug anything into this. So again, this is another scenario where this is all real for the domain. Now let's check out the range, and we'll just look up and down on the graph. If I look from the bottom or from -infinity, the graph actually starts at -5. Okay, so it starts at -5, and then we have some issues because it kind of doesn't cover anything until we get up to 0. Okay, and then that's when we go all the way to infinity. So in order to write that, we'll say, hey, we start at -5, and we include -5 with our bracket. And then since we don't go anywhere, we just kind of stay at -5. Okay, so we end right there. We start there, we stay there. Then we'll do a union, and we go all the way up to 0. Okay, so that's where our next point starts, and we're going to include 0. And then we go to infinity. Yay. All right, guys. I want you to bring your completed guided notes device on Monday because we'll practice graphing these absolute value functions. So make sure on Monday you have your guided notes completely complete.